Hello viewers on YouTube. In this video tutorial, I would like to share with you everything you need to know about quartile in statistics. Quartile helps us to divide distribution into 4 equal parts. And one of its functions is that when we have large amount of distribution and we want to select a particular or a specific data from it, it might be a little bit difficult for us. But with the help of quartile, we can know the category of the data we want to select and just select it right from there. Perfect. Now, the formula that helps us to find the quartiles for a distribution for group and ungrouped data is different. And we're going to disclose everything with you in this video. So let's begin with the formulas. So for an ungrouped data, Q1 is simply equals to 1/4 of n, where n is the number of the distribution. Q2 is simply equals to 2/4, which corresponds to 1/2 of n, and lastly Q3 is 3/4 of n. N is number of distribution. Now keep in mind, this doesn't give you the exact data, that is the Q1, Q2, Q3, and so on. But instead, this gives you the position where the first quartile, second quartile, and third quartile falls. Often case, students usually used to mix this up. Calculating Q1 with this formula doesn't give you Q1. It gives you the position where Q1 is, which means whatever answer you have here, locate the data that is at that position, and that data is your Q1. Keep that in mind. We're going to use that when we begin an example. Now, there's something called interquartile range, written for short as IQR. From the word range, range simply means maximum minus minimum. So interquartile range is simply equals to Q3 minus Q1. Keep in mind, not the value of what you have here and what you have here. That's not the value you are subtracting. You are subtracting the value you identify, the value you figure out, the value that is at this position and this position. Please be careful. Perfect. Now, we also have semi-interquartile range, written for short as SIQR. And this simply equals to average of this result. That's IQR divided by 2, which is indeed equals to Q3 minus Q1 all divided by 2. Now, this applies to group and ungrouped data. These two formulas for interquartile and semi-interquartile. Now, lastly, we have to discuss before we begin an example is called an outlier. An outlier is a data that tends to fall outside a certain range. Now, whenever a data from a given distribution is above Q3 plus IQR multiplied by 1.5, then such data is said to be an outlier. Similarly, whenever a data is below Q1 minus IQR multiplied by 1.5, then such data is said to be an outlier. Now, you notice that this can be written in interval notation. So generally speaking, an outlier is any data that falls outside this range, Q1 minus IQR multiplied by 1.5 to Q3 plus IQR multiplied by 1.5. So any data that falls outside this range is said to be an outlier. So how do we find it? This is how to find it. But to ease your understanding, let's go over some examples. So I haven't discussed about the formula that helps us to find the quartiles for a group data, but for now, let's go over some examples. Example number 1. Consider the distribution on the board. Feel free to pause the video and find the first quartile, second quartile, and the third quartile. So what exactly will be the value of Q1? Well, notice that we have 6 distribution. The value of n is simply 6. So definitely Q1 will be data at the position of 1/4 of 6. 2 reduced to 2, 2 reduced to 3. So this is simply 3 by 2. and 3 by 2 is simply 1.5. So what data is at the position of 1.5? Well, this is the first and this is the second. 1.5 is a decimal. How do we find the data at that position? In this kind of scenario, you can take the average of these two values. But taking the average, we have 3 plus 6 divided by 2. That gives us 9 over 2, which is 4.5. But 4.5 is not among the distribution, so that won't work. But if you find the answer you have in the distribution, you are good to go. But what if it's not there? Just like this kind of example. What I would suggest is to approximate this value. Since 1.5 can be converted to 2 to the nearest whole number, then selecting seeds is not a bad idea. So 6 is Q1. Are we together? Perfect. Now what about Q2? Q2 is simply equals to 1/2 of n, which is 6. 2 here 1, 3 here 3, that gives us 3. So the data at the third position is simply 9. Now keep in mind that distribution must be arranged in ascending order. This has already been done, that's why we skip that step. So Q2 is simply 9. Now Q3 will be 3/4 of n, but n is 6. So that's simply 3 over 4 times 6. 2 here 2, 2 here 3, and 3 times 3 gives us 9 over 2, which is 4.5. So this is the first data, second, third, and fourth, and this is the fifth. 10 plus 12, that gives us 22, and 22 divided by 2 gives us 11. However, 11 is not in the distribution. So we're going to do something we do earlier, something similar. 4.5 can be approximated to 5 to the nearest whole number, and finally we can select 12 as our Q3. And that's how to easily find the first, second, and third quartile of an ungrouped data. Now what about IQR? IQR is simply Q3 minus Q1, which is in this case equals to 12 minus 6, and that gives us 6. So that's the interquartile range. And SIQR, which is half of IQR, will simply be equals to 3, as half of 6 is simply 3. Now what about outlier? Can we know if any of the distribution is an outlier? Yes, we can. So let's see if there's going to be any of these distribution that's going to fall outside this range. So that's going to be Q3 plus IQR times 1.5. IQR is 6. So if we have 6 times 1.5, that will give us 9. So Q3 plus 9, well, that should come after the first one because it's a range. We are considering of smaller to bigger. So we could are considering Q1 minus IQR times 1.5, which is 9, all the way to Q3 plus 9, which is IQR times 1.5. Q1, we got that to be 6. 6 minus 9 is negative 3. Then all the way to Q3, we got that to be 12. And 12 plus 9 is simply equals to 21. So is any of the distribution, is any of them an outlier? Absolutely not, as none of them is outside this range. So that's how to easily identify if any data from a certain distribution falls to be an outlier or not. I hope you understand that. On to example number 2. Consider this distribution. Feel free to pause the video and find Q1, Q2, Q3, IQR, SIQR, and determine if there's an outlier among the distribution. So let's begin. Q1. But before we proceed forward, this distribution is not in ascending or descending order. As you can see, it's scattered. So let's arrange them. So what is the least number here? That's simply 37. So we have 2 37. After 37, we have 38. We have just 1 38. After that, we got 39. We got 2 39. And after that, we have 41. And we got 141. And after that is 42. We also have 142. We also have 143 and another 43. So therefore, we have 243. And finally, we have 144. And boom, we have our distribution to now be in ascending order. Arranging it in descending order doesn't cause any palaver for you, as everything will still go perfectly. So now we can proceed on finding Q1. Q1 is 1/4 of n. What exactly is n in this case? It is that we have 2, 4, 6, 8, and 10. 10 distribution in number. So therefore, we're going to have 1/4 of 10, which is simply the same as 5 over 2. And 5 over 2 is 2.5. So this is the first, the second, and the third. So let's add this up, the second and the third, and see if the result is still within the range. 37 plus 38 gives us 75, and dividing this by 2, we got 37.5. But unfortunately, 37.5 is not among the distribution, so we're going to select 38. This equals 38. Perfect. But I would suggest, in case your teacher said you can leave your answer as 37.5, you are good to go. But this is suggested. Perfect. Now, what about Q2? Q2, we said, is 1/2 of n. That's 1/2 of 10, which gives us 5. So the fifth distribution is simply equals to 39. So therefore, Q2 is simply 39. Now what about Q3? Q3 is 3/4 of n, and that's 3 over 4 times 10. 2 reduced to 2, 2 reduced to 5. Then we have 15 divided by 2, which results in 7.5. So we need the distribution or the data at 7.5th position or 7.5. So first, second, third, fourth, fifth, sixth, seventh, then we have 8. So 42 plus 43, does it give us any value within the distribution? 42 plus 43 divided by 2, 42.5, no amount. So 43 is good to be selected. So that is our Q3. Now that we have Q1, Q2, and Q3, we can find IQR. So IQR is simply Q3 minus Q1, and that's simply 43 minus 38. And therefore, we have 43 minus 38, we got 5. So that is our IQR. And finally, we can find SIQR and have 5 by 2, which is 2.5. So that's our semi-interquartile groups. Now what about an outlier? Is there an outlier among this distribution? Let's confirm. We said an outlier is any data outside this range, Q1 minus IQR multiplied by 1.5 all the way to Q3 plus IQR multiplied by 1.5. So Q1, earlier we got that to be here, 38. So 38 minus IQR, we got that to be 5. So 5 times 1.5, 5 times 1.5, we got 7.5, 7.5. Then Q3, we got that to be equals to 43. Here it is where, so we have 43. Then plus IQR, which is 7.5 times 1.5, 7.5. So therefore, we have 38 minus 7.5. That gives us 30.5. And finally, we have 43 plus 7.5. 43 plus 7.5, that gives us 50.5. 50.5. So the question is there any data among this distribution that is outside this range? Well, it is that the result is absolutely not. There's no data that is outside this range. It means there is not an outlier within this distribution. So that's how to easily find or figure out if there's an outlier among a distribution or not. I hope you find this helpful and understandable. Now let's move on to group data. How do we find the quartiles for group data? Let's talk about the formulas first. To find Q1 for a group data, the formula that helps us to do that is simply equals to L1 plus, in a bracket, summation of F divided by 4, the minus F sub C entirely divided by F sub n, then multiplied by H. I'm going to explain what all of this symbols make sense. L1 is the lower boundary of the Q1 class. So it means if you are doing or dealing with a group data, if the question says find the Q1 class, you need not to stress yourself using or doing all this. As Q1 class, finding Q1 class is different from finding Q1 mark. You understand? Finding Q1 mark, that is, the exact first quartile. But Q1 class is the class that first quartile is. Are we together? And that's how it works for all other quartiles as well. Now, summation of F is not something new to you. You already know what it is, as the sum of the frequency. Now, what about F sub C? F sub C is simply the cumulative frequency below the Q1 class. Are we together? So once you find the Q1 class, the cumulative frequency below the Q1 class is the F sub C. So let me just write Cm, cumulative frequency below Q1 class. And lastly is F sub n, or second to the last. That's frequency of the Q1 class. Is frequency of the Q1 class. Frequency of Q1 class. And lastly is H, that's simply the class height. The difference between either the upper and the upper limit of the first class and of the second class, or lower limit of the first class and of the second class. That gives you the class height. So these formulas also work for all other quartiles. If you have to find Q2, for instance, now the reason is you have to change is this one, change to L2. That will be the lower boundary of the Q2 class. And so you go over an example, you see what I'm saying makes sense. Now this will not be summation of F over 4. It will now be 1 second of summation of F. You know, just like the group one. It's now 1 second of summation of F. You know, it's supposed to be 2/4 of summation of F. But 2/4 of summation of F is the same thing as 1 second of summation of F. Now, F sub C will be the cumulative frequency below that Q2 class. F sub M will be the frequency of the Q2 class. If it is Q3, we'll consider an example, okay? This will be lower boundary of the Q3 class, 3/4 multiplied by summation of F, cumulative frequency below the Q3 class, and frequency of the Q3 class. And that's how it works in Excel. So now let's apply this into good use. So consider the frequency distribution tally table on the board. Feel free to pause the video and find the first quartile, second quartile, third quartile. You know, I said the only formula is the difference. For IQR and SIQR and Outlier, they are the same for both group and group data. So you find the rest as well. And after that, you can pause it to confirm if you got it right. So we have the class interval and the frequency. First and first, we need the class mark X. Then after that, we need the cumulative frequency CMF. Then after that, we need the class boundary. So that's class boundary. But to save our time, we need not to find a class boundary of the entire class, but the ones we are going to be making use of. But since we will be finding all the quartiles, I suggest we do everything so you can just see how it goes. So let's find the mark. To find the mark, you add these two values and be dividing them by 2. There's another way around. So 0 plus 4 is 4 divided by 2 is 2. 5 plus 9 is 14 divided by 2 is 7. 10 plus 14 is 24 divided by 2 is 12. 15 plus 19 is 34 divided by 2 is 17. Then finally 20 plus 24 is 44 divided by 2 gives us 22. Like I said earlier, there's another way around. Once you do the average for the first one, which you got 2, then find the class height, which I discussed earlier. I said that was the difference between the upper limit and the lower limit. This is called the lower limit, while this is called the upper limit. Lower, upper, like that. So you find the difference between the lower limit of the second class and that of the first class. You see that the result will be the same as 9 minus 4. So that's just the value of h. So h is 5. So keep on adding 5 to these values respectively. So you keep on adding it to the preceding ones to get the preceding ones. So 5 plus 2 gives you 7. Understand? We have that. 7 plus 5 is just 12. 12 plus 5 is 17. 17 plus 5 is 22. So either way, we are on the safer side. Now that we have the class mark, what about the CMF, the cumulative frequency values? Cumulative frequency value for the first mark or for the first class interval is its frequency. Now the next one, you'll be adding the next frequency to it. Okay, 3 plus 6 is 9. 9 plus 8 gives us 17. 17 plus 4 is 21. 21 plus 3 is 24. The last class interval or the last class mark have its cumulative frequency to be the sum of the frequency. If you add all these frequencies together, you will end up having 24. So that's one way in which you can confirm if your cumulative frequency has been done properly or not. Now, what about class boundary? To determine class boundary, it's usually in this form. But the difference is that you will be subtracting 0.5 from these values, from the lower limit, while you'll be adding 0.5 to this upper limit. That will provide a class boundary for you. So 0 minus 0.5, I got negative 0.5 to 4 plus 0.5. That's 4.5. And this continues to 4.5 all the way to 9.5. Okay, just keep on subtracting and adding 9.5 all the way to 14.5, 14.5 all the way to 19.5, and finally 19.5 all the way to 24.5. And we have everything we need to proceed on finding the quartiles. So let's proceed with Q1. We said Q1 is simply equals to L1 plus the summation of F divided by 4, the minus the frequency, the cumulative frequency below the Q1 class, divided by the frequency of the Q1 class multiplied by the class height. Okay, I'm not sure this is specific enough, but let's proceed. So let's find the Q1 class. How do you find the Q1 class? Well, the goal is just to find 1/4 of the summation of F. So Q1 class, that's what I'm saying earlier, that if you have to find the class, Q1 class, that's simply 1/4 of summation of F. Now if it's Q2 class, that will be 2 seconds or 1 second of summation of F. Q3 class, that will be 3/4 of summation of F. Now 1/4 of 24. 24 divided by 4 gives us 6. So the class interval at the 6th position is the Q1 class. So this is the 3rd one. Then 6th one will be somewhere around there. Okay, so therefore the 5 to 6 class interval is the Q1 class. So it's simply 5 to 9. So 5 to 9. Are we together? If you write this class interval 3 times, you write this one 6 times, you write all of them, you will observe that by the time you start counting, the 6th class interval will fall to be this one. Are we together? Because that's where that range is. Perfect. In case you might have a question, how I got 5 to 9. It's simply 5 to 9 class interval. Now let's find the corresponding class boundary. You see that in line with this is 4.5 to 9.5. So therefore the lower class boundary L1 is 4.5. So that's how to find your L1. Okay, this one is L1, this one is L2. Lower class boundary, upper class boundary, just like the limits. Okay. Now summation of F, we got that to be 24 already. And what about F sub C? The cumulative frequency below the Q1 class. This is the Q1 class. The cumulative frequency below it is 3. So therefore, F sub C is equal to 3. Class height, we got that earlier to be 5. H is equal to 5. Now finally is Fn, the frequency of the Q1 class. So this is the Q1 class and this is its frequency. That's simply 6. So F sub n is simply 6. We have everything we need to find Q1. So therefore, we can, okay, let me use this side. We can proceed on finding Q1 direct. So Q1 would be equals to L1 4.5 plus in the bracket summation of F 20 divided by 24 divided by 4, the minus F sub C, we go that to be 3 divided by F sub M is 6 multiplied by 5 H. Very good. So now we can get rid of the formula right now. So therefore, Q1 will be equals to 4.5 plus 24 divided by 4 is 6. 6 minus 3 is 3. So we have 3 over 6 multiplied by 5. That's 4.5 plus 1 over 2 times 5. So that gives us 4.5 plus 5 over 2, which is 4.5 plus 5 over 2 is 2.5. 2.5. When we add this up, we have 7. So this is our Q1. And that's how to easily find the first quartile of a group data. I hope you find this understandable. Now what about Q2? Let's also find Q2 as well. To find Q2 will be equals to L2, lower boundary of the Q2 class, okay, plus, now it won't be summation of f over 4. It should now be 1 second summation of f. That's summation of f over 2, okay, perfect. Summation of f over 2, the minus, now f sub c this amount will be the cumulative frequency below the Q2 class. Are we together? Perfect. Then divided by f sub m, the frequency of the Q2 class. Good. Then entirely multiplied by the class height. It's only the class height that are usually remain unchanged for these formulas, or in these formulas. So therefore, what will be L2? Let's find the Q2 class. So the Q2 class will be equals to, so that will be 1 over 2 times summation of f. That's 1 over 2 times 24, which is what? 12. So what class interval is at 12 position? When we get to 9, we exceed this 5 to 9. So 12 will be 10 to 14. Perfect. So that's 10 to 14. Okay. So the class boundary in line with it is 9.5 to 14.5. So therefore L1 is 14 of yes, 9.5, not 14.5, 9.5. Okay. So now that we have L1, we can find the rest. What will be FC? So FC, f sub c, would be the cumulative frequency below the Q2 class, that's 9. Okay, so we got that to be 9. What about FM, frequency of the Q2 class, that's 8. So we got that to be 8. H is still 5. And finally, summation of F is 24. So we have everything we need. That will be Q2, L2, 9.5 plus the bracket, summation of F, that's 24 over 2. The minus f sub c is 9, then divided by, and do it again, divided by f sub m is 8, then multiply by h, which is the class height, that's 5. Perfect. So now we can have Q2. So Q2 would be equals to 9.5 plus 24 divided by 2 is 12. 12 minus 9 gives us 3. So we have plus 3 over 8 times 5, which is the same as 9.5 plus 15 over 8. So 15 over 8 is simply 1.875. So that will be 9.5 plus 1.875. And if we have 9.5 plus 1.875, we got 11.375. 11.375 is still within the range of the class distribution or the distribution. So we are good to go with that. So that's how to easily find the quartiles for group data. Now, Q3 will be an exercise for you. And at the same time, I'm going to give you a whole exercise as well as an assignment. Okay. So make sure you share your solution via the comment section below. So find Q3 to this solution or to this problem. Now, what about the SQR or SIQR and IQR? Like I said, SIQR and IQR formulas is not different. So once you find Q3, you just find the difference between Q3 and Q1, which you got to be 7 earlier, and got your IQR. After that, find the SIQR and you have your answers. You can also find the outlier, know the range of the outlier, and see if there's any outlier among this distribution. So that's it for this video, and I hope you find it helpful and understandable. Thanks for watching. See you in the next video. Bye for now.